Hey, Dave here. In this video, I'm going to repurpose a PC and turn it into a pfSense firewall slash router. And so you can buy appliances that can run pfSense, but if you have hardware lying around like this, then you could build your own and download the software for free. So this is a PC that I built in 2012. Originally, it was an HTPC, a home theater PC, and it had the TV tuner and RAID 1 configuration and all kinds of stuff. Worked great, but I didn't really use it that much. Then I brought it to my lab and I was using it as a server 2012 for a while. But all my Windows servers I run virtually now, so this box is just sitting. It's fairly clean, it's in good condition. And the really nice thing about it is it has all these network connections. I've got an embedded network connection, network adapter, on the motherboard, and then we have two network cards. We've got this one, a single, and we've got a double here, a dually. So we've got two Intel cards, and there's even a wireless card here as well, which we could possibly use in the future. I'm going to pull that out. But my goal is to use this for the console and for management. These two will be for the LAN, the local area network, and we'll team these together and connect this to a Cisco switch. And this one will be for the WAN, the internet connection. So we'll have that single for the wide area connection. Now I have several networks and I've got several public IPs. So this is going to be used on one of my test networks to start. And what initiated this was this Soho router that I had on this one test network failed. Power failed on that. So that's being put away. And instead of buying a device from Netgate or elsewhere, I figured I'd just build my own because I have this guy lying around here. But we have to do some work here to repurpose this. There's a couple of things we want to do. First of all, I've got an optical drive. I'm going to take that out. And I'm going to take this hard drive frame out so we can take a look in here a little bit better. But generally what I do is I remove unnecessary hardware like the optical drive, and in this case this wireless card, although you could use that. That could definitely be useful if you want to have a wireless network as one of your local area networks within your infrastructure. And then I like to clean out the system. Clean out the fans, blow everything out, vacuum out, and then also check the power supply. Now, this power supply really hasn't been used that much. Most of the time, this computer was sleeping or just off, so it wasn't really used that much, and it's fairly clean. It is 6.5 years old, this computer is. So it's definitely something I'm going to check with my power supply tester and clean out the fan underneath and the filter for that. But if the computer had a lot of use, you may want to look into replacing the power supply. And there's a couple fans over here too, so I'm going to pull those out and clean those as well. So first, let's get out the optical drive and the card and this hard drive so we can take a little bit of a closer look. Okay, so I've taken out that optical drive and taken out the wireless card and disconnected this. This is the hard drive frame, and you can see here that we have a solid-state drive. So that should be great for running pfSense. And we've got lots and lots of additional wires here, so we're going to try to remove what we can. If I had additional funds, I might consider, especially if this power supply is older, might consider swapping this out and using a modular power supply. Because all we're going to need for the power supply, we really aren't going to need much power, and we're just going to need the one SATA connection for power for this hard drive. And then the main power, then the 4-pin power for the CPU, and then possibly fans as well. So really not much to connect, so a modular might be better, but I'm going to use what we have here. And looking inside here, it looks fairly clean. I don't think I'll even have to remove the RAM. I might just take a look, but I think that's really clean. Mainly it's these fans. They have filters, so I'm going to pull these out and clean those, and then give everything a nice cleanup with the computer vacuum and the blower. Now, when I do that, what I like to do is that you notice here the fans can move. And so what I like to do is I like to disconnect all the power and then put some type of stopper on the fans or electrical tape them or use computer tape. And so that works well to help to try to stop discharges. You might get a discharge if the fan starts spinning a lot. So we don't want that. So we're going to disconnect all the power connections here. And so we have, on this guy, we have actual Molex connectors for the fans. You know, that's something we could upgrade also. But these actually run pretty quiet. These are nice fans in this case. So I probably won't have to do that. I've had this box right next to me, and it's actually done pretty well. But you could upgrade and go to like 4-pin fans or what have you, and change these out if they're too loud. And quite often you'll have a PC or a server case that the fans are just too loud, especially if you want them in a lab or near your desk. So you swap them out with 4 pins as long as you, or 3-pin connectors, as long as your motherboard supports that. So you got to make sure about that beforehand. But I think I'm going to leave these. And so what we're going to do now is clean this guy out and clean up the cables a bit so that we have a little bit more space. And then we'll continue on. Okay, so I just cleaned this guy out and just wanted to show real quick what I like to do when I'm cleaning out all the dust from a computer. It especially collects in the fans. And so if you got a whole lot of dirt and caked on dust and all that, then you're going to want to remove the fan assembly from the CPU if that's really dirty, and remove the heatsink. If you do that, then you're going to have to reapply thermal compound when you put it back in. And sometimes you have to take apart these fans. Didn't have to do that with this guy. The filters on the sides were pretty dusty, but I was able to get it all out. The technique I usually use is to use a vacuum on the outside. And so suck out as much as I can from the fans on the outside, and then use a blower simultaneously with that vacuum, because that's usually where the bulk of the dust is in these fans. And so I'll run the blower and the vacuum and do it kind of simultaneously. And so this blows the dust out and the vacuum pulls it up so we don't make much of a mess, and it works very well. And any vacuum will do. If you have a computer vacuum, that's fine, but any vacuum will do with that. So I did that with both of these fans, and a good blower, this works very well, that you plug in. This is the kind of thing that you want, as opposed to canned compressed air. Also a third one was over here, so did that one as well. And if we take a look here, you can see they are super clean now. And really no dust got anywhere. No dust got anywhere inside the case. It all got compressed out and was on this side, so it worked very well. And then I just did a little bit more blowing out of everything. Really nothing else came out. Heatsink and fan are clean. Everything else is nice and clean. So that's good. And at this point, we'll kind of start putting everything back together. And so I need to put a cover in here. And that's why I always keep my motherboard cases. Whenever I build a system, I'll keep the box that came with the motherboard and keep all the extra parts in that box. And so we've got one of those, and we've got slot covers for this as well. We'll put that in where we took out that wireless card, plug everything in, do some cable management, and get them ready for the install of pfSense. Okay, so as you can see, the system is running now, and I did a couple things here. I got rid of that frame for the optical drive. That's gone. And I did some cable management here, so everything's nice and tightened up. And moved stuff away back here because there's a fan here also. And so kind of cleared some space for airflow. So all these fans, these 3 and the one on the bottom, are all clean. All the filters are clean. CPU fan is clean. Should run well now. I also checked the lithium battery in here. Took that out and checked it with the multimeter. It's just above 3 volts, so we'll leave that in there. And I had to update the BIOS And so I did that and also made some configuration changes. You can see the update for the BIOS here. That's up to the 2014. That's the latest one. And did some configuration changes and added a password. And then I went to grab the image for pfsense. But you got to get the right image from here. And you have a couple options here. You can grab the image as an AMD 64. And again, they prefer that because, you know, most of the devices out there are going to be AMD based, but you can still install it on Intel. Or you can grab it for the Netgate device if you need that. So I selected this, and then you have to select the right type, depending on whether you're doing this from optical drive or from USB flash drive. And then you want to image that to your USB flash drive. So I've done that. And then we went ahead and started the install of pfsense. Okay, so I wanted to show the installation of pfsense, and I actually recorded the install onto the box, but I kind of botched the video. So it's a little bit easier to just show it within a virtual machine. I've already created the virtual machine, and I just wanted to run through the install steps a little bit before I show the configuration that I did for it. So we'll go ahead and power on this virtual machine now and maximize this window. This is based off of FreeBSD. So Linux-like, very similar to Linux, but FreeBSD is a great operating system. You could actually build what pfsense does on your own with maybe 15 or 20 commands to get that basic LAN to WAN firewall going. A bunch of ifconfig commands and others. So it wouldn't be that difficult to do within FreeBSD, but pfsense puts it all together for you and gives you lots of functionality and a great GUI to interface remotely from a client side. So we'll run through the install now. We'll accept the copyright and install pfsense, enter. So it's all text-based for this installation, and the local configuration is all text-based as well through a menu. We'll select the default key map and guided disk setup for the disk. Now, if you had any types of information on the disk or partitions, then it would ask you to make modifications to that. And then it would delete anything that's there and then go ahead and install. Okay, and boom, the installation is finished. And it takes about the same amount of time if you're doing it from a USB flash drive. Didn't take long at all when I actually did it on the system. So we'll just say no for any additional modifications within the shell, and we'll reboot. Okay, so as I was working on the system, I also worked in the BIOS. Of course, I was changing the boot order so I could boot from the USB flash drive and set a password on the BIOS. Important to have a complex password on there. Okay, so it's going through a bunch of the configurations now, all part of the initial boot up. And it takes a couple moments to get everything configured. So we'll let that finish and be back when it's done. Okay, and it completed, and it sees the WAN and LAN connections. Now, these are virtual connections, but it's basically essentially the same on my main system. The only difference is I have an additional connection called optional 1, which I'll show how I configured in a little bit. That I'm using for remote administration. So we have our LAN card, which it automatically configured as a Class C 192.168.1.1 private IP, which is very standard. And then we have the WAN connection. And that's generally how it looks at these, as EM0 and EM1. So if you didn't want to use this IP, you could reconfigure everything. And you can assign interfaces to different network cards. Maybe it read this in reverse. Maybe you'd wanted the LAN card to be using EM0, that physical device, and the WAN card to use EM1. Well, you could change that. You could go and type 1 for assign interfaces and specify which is which. And I do actually have a third virtual connection here. So it could be that we want them a little bit different. It asks if you want any VLANs. We're going to say no for that. And then it says enter the WAN interface. Well, it could be that EM1 needs to be the WAN interface, or maybe EM2. So we'll specify that. and then it says enter LAN interface. That could be EM0. And then an optional 1 interface, which I might use for remote administration, or it could be a separate LAN or LAN segment. So we'll say EM1 for that one. And now it gives you the assignment that you've selected. And if you want that, say yes, and enter. And it'll apply that information or write that configuration. Okay, so now that's configured. The WAN is set up as EM2. The LAN is EM0, and the optional 1 is EM1. That's what I'm going to connect to for the remote administration. And the LAN card got 192.168.1.1, as we mentioned. We can modify that. I don't want to use that. I mean, we could connect with that and then modify it remotely from our workstation through the browser. But it's a good idea to just change it here to the initial IP that you want. So we'll do number 2 for set interface IP address, and we'll select number 2 for the LAN card. Press enter, and it says enter the new LAN IP version 4 address. Now I've been modifying my networks, so I'm going to use 172.18.0.1 for the LAN IP. Press enter. Then it wants a subnet mask in bits. We'll do 16 because that's 255.255.0.0. Press enter. And it asks for a gateway address. Well, for the LAN, we don't need that because this basically will be the gateway for all the other clients. So we'll press enter for none. And not using IP version 6 right now. So enter for none. Do we want DHCP? I mean, that's a good thing. You can use it and your clients can get IP addresses automatically, but I don't need that. I have DHCP running separately. So we'll say no. And we'll leave. It's asking, do you want to revert to HTTP as the web configurator protocol? By default, I like to connect with HTTPS, although the security won't be there until we get a certificate rolling. But we'll say no for this to leave it as HTTPS. Okay, and it does the configuration, and it tells you here now, it says you can connect through your browser from a remote computer by just connecting https://172.18.0.1. And that's that. You could configure everything from here if you wanted to. Press enter to continue. You could configure the WAN address, the optional address. You could do all kinds of stuff from here. Do testing. You could really have the thing running by doing this locally. But I want to do a lot more configuration here and really set up the remote configuration for optional 1 and set up link aggregation for the LAN. So I'm going to go and do all those configurations, and then we'll come back and show what I did. Just show basically how it's set up when I'm done. So I'll be back in just a bit. Okay, so I've done a bunch of configurations here, and I've actually changed the IP scheme for some of my test networks. And so I've done a lot of stuff here. Let's take a look. First of all, I changed the name of the system and just calling it dpro fwpf1, and it's on the dpro42 domain, dpro42.com. So I added that information in and created a new user. By default, you connect as admin, but normally what I like to do is take that admin account or root account, put it on the shelf, and keep that as a backup in case anything goes wrong, and use another account that you create. So we do that from System, go to User Manager, and create that additional account, adding the admin's group membership, and it automatically gives you the ability to do the web configurator. I also added this system shell account access, so I can connect via SSH. So now I'm using the sysadmin account. That's just the name I gave it, and keep that admin account on the shelf as a backup. Make sure, of course, we have a complex password. Now you'll note it says sysadmin at 172.19.0.254. That's the local IP that I'm connecting from my system. And so I did a lot of things with the networking. So let's take a look at that, and we'll look at the interfaces here. Now, the LAN, if we click on the LAN interface for all the servers and virtual machines that I have, and go down here, you'll see that I configured that as 172.18.0.1. So this is Class B private. Really, most of what I do is classless, but you could look at it as Class B private 172.18. So that's where the actual data flows through for all the virtual machines and servers and all that. They're on the 172.18 network now. No subnetting. It's /16. So this is 255.255.0.0. So remember, that's 172.18. That's the LAN interface. But what I wanted to do was I wanted to set up link aggregation for that LAN interface, because there was two RJ45s on the network card, because they will be communicating with other local area networks, which are also link aggregated. So I wanted to get as much bandwidth through as possible. But to do that, you can't be connected on that LAN connection. You have to be connected on a separate connection. Otherwise, it's virtually impossible to set it up. It can be done, but it gets tough and gets confusing. So the better thing to do is always to have an administration interface. And so that's what I set up with optional one. So I set up optional one when I was first connected on the LAN interface, enabled it, set it as static IP, and then put that on the administration network, which I'll be using. That's 172.19 instead of 18. So that's the admin network, configuration network that I use for all the servers now, 172.19. And .18 is the LAN, the local area network used for all the data, all the actual virtual machines, servers, and so on. Also /16, 255.0.0. And so I set that up, but by default, you can't connect. So you have to go to the firewall and set up rules. And I actually had to add this rule. And this is just a standard any rule, IP version 4. Just added that on. Star for TCP and UDP. And all ports, all destinations. If you look at the LAN, it has that same type of thing. So that all the computers on the LAN can connect out through to the wide area connection, which is by default blocked from the outside. And you can do all kinds of rules with this. It's a regular firewall. You can do whatever you want. You can do this graphically, or you can do it locally at the system on the command line. But without that optional one rule, I wouldn't be able to do anything. So I had to set that up so I could actually connect. Once that was set up, I logged out of that LAN connection that I was connected to and logged on as 172.19.0.2, that optional one IP address. So once I did that, then we could start working with the link aggregation on the LAN adapter without having to worry about any connectivity issues. So what I like to do is I like to set up an endless ping to the IP address of the local area network, which is 172.18.0.1. That's the LAN interface for the firewall. And this way I can watch and see if it goes down and when it comes back up, because you're going to get that type of thing when you do link aggregation. So I went to link aggregation here and then went to create one. And when I created one, I was able to select the different adapters, EM0 and EM1. That's A4 and A5. And selected those so that they could be connected together. And then you have multiple options here. I selected LACP so we could have that link aggregation control protocol utilized through the Cisco switch that they're going through. And we could do other options here. We could do failover, and that's good as well. And generally that's all you need or all you really want, because really if you just have one LAN and it's going out to the wide area network, your bottleneck is going to be your connection to your ISP. So do you really need two 1 gig or two 10 gig connections aggregated together? I don't think so, not usually. But I have other local area networks that have other servers, and they will communicate with each other. Both of those LANs will communicate with each other. So I wanted to get that actual link aggregation going. But otherwise, I would probably set up failover or maybe load balancing. So once I selected those, go back to the interfaces, and what the LAN shows normally is EM0 or EM1, and then what you do is you select that link aggregation channel that you set up, and I just called it LAN lag. Now, when you set that, that's when you lose connectivity here, and it'll say request timed out with the endless ping that I'm doing. And that's because you have to set it up on the switch. So it has to be cabled correctly. And then you go into the switch, go into port management, link aggregation, lag management. And what you do is you set up a new link aggregation connection. And so that's what I did here. I was having a little bit of an issue because I was trying to use an older one, this lag 2. That doesn't work on the Cisco switch. Got to create a new one. And so created a new one, named it, and then selected LACP enable. That was the issue. Couldn't actually get that running properly. So I had to create a new link aggregation. And just select the members, the ports, port 2 and 3. That's what it's connected to. And you can see it's enabled and the link is up. And once I did that and saved the config, the link was indeed up and the replies started coming back in from that IP. So it's a lot easier to configure that whole thing from a connection on a different IP network, on a different interface altogether. And that's one of the reasons I'm using optional 1, just to use it as an administrative interface. So that's that. And optional 1 also connects out to the WAN, so it can get out to the internet if need be. But again, it's really an admin interface. I'll probably never use that, but it's good to have it for now. In some cases, in a secure environment, you might need to shut that down and create a rule where there is no network address translation between the WAN and optional 1. But it has it for now, and it's the administration interface. The LAN connection is all set up. All the servers and clients and virtual machines can connect out and out to the internet through the WAN interface. So that's all good with link aggregation. So we get 2 gigabits per second on the LAN side instead of just 1. I don't think I showed DNS. DNS you set up if you go through the wizard, but you also find that in the general setup. So you can set up your DNS servers here. Your wide area connection won't be able to get any name resolution if you don't have your DNS servers set up. And this is just from my ISP. Okay. And finally, the backup. If we go to services, auto config backup, and backup now, you can name the backup. It'll back it up locally. You also probably want to back up remotely as well. Get those settings backed up. And if we go back here to the main page, you get lots of information here. There's plenty of diagnostics that you can do, and there's plenty of ways to look at the status of the system. But the dashboard, if you just click here, the dashboard's really nice. It shows you what's going on. They just came out with a new release of this just after I did the install. It shows you the package type that you're running, how long it's been running for, and the temperature, CPU usage, memory usage, disk usage. So it's a nice snapshot of everything that you have going on here. And then over here you see the interfaces and how they're connected and what IPs they're using. And I'm blocking out the IP of the wide area network right now. So you see all this information, and it's pretty good. It's a pretty good snapshot of the info. And lots of ways to look at the status of the system and lots of diagnostics as well. Plus, lots of services you can run. So pfsense, pretty cool for a free download. And for repurposing a system, it works very well. Very powerful connection right now. I did some tests, and it's pretty fast. It's pretty fast through the internet, much faster than, say, a standard Soho router. It can send a lot more data per second, so I'm definitely satisfied with the usage of this right now. So that's some of the config. If you have any questions, feel free to contact me at my website. And that's about it for this video.